are going to explain 3D equilibrium. First of all, we need to know what is 3D equilibrium. 3D equilibrium is when forces acting on an object which is at rest are balanced. Then the object is in a state of static equilibrium, which means no translations and no rotations. In 3D equilibrium, we deal 6 equations, which are: first, summation of F resultant equals 0 and summation of M resultant equals 0, and that become summation of Fx equals 0 and summation of Fy equals 0 and summation of Fc equals 0. On the other hand, the moment about x direction equals 0 and the moment about y direction equals 0 and the moment about z direction equal 0. Now, how to solve 3D equilibrium problems? First, draw free body diagram. Second, write the equations. Third, solve equations for reaction forces. The last thing, check your answer and the direction. Now, we will solve some problems.
We solve here this problem about 3D equilibrium. We have here a uniform steel shaft, has a length 10 meter and weight 2000 Newton, and two supported points A and B. Find all forces in that shaft. First of all, draw free body diagram and determine the forces. On A, that's two direction or reactions forces, AX and AY, and on B, that's three forces, BX, BY, BZ. The dimension of B from the origin on x-axis 8 meter and y-axis 4 meter, and z-axis is 0. And the dimension of A is 0 in x and 0 in y, and h unknown in z. How find the h? Look here. 10, the length of shaft, equal square root under square root 8 square plus 4 square plus h square. That means h equal 4.5 meter. To solve the forces on A, AY and AX, we should put MB or moment about B equal 0 to solve that forces. Why MB equal 0? Moment about B equals 0 because it's equilibrium. That means MBX also equals 0 and MBY equal 0. MBX equal, that's two forces acting on that moment, the weight and the AY. Weight 2000 multiplied by the distance 2, the distance from here to here 2 meter, positive because it's anti-clockwise, and AY multiplied by distance minus y minus because it's clockwise equal 0, then ay equal 889 Newton. Then mby equals 0, also two forces acting on it, the weight and ax. The weight minus 2000 multiplied by 4, the distance, minus y minus because clockwise, the move clockwise, and ax multiplied by the distance, positive because anti-clockwise, equals 0. That's mean ax equal 1778 Newton. To find bx and by and bz, we put the summation of f. Summation of f x equals 0 and summation of f y equal 0. Summation of fz equal 0. That's because it's equilibrium. ax minus bx equals 0. That's mean bx equal bx equal ax, and summation of y equal 0. ay minus by equal 0. by equal ay here. Summation of fz equals 0. The forces in z, b, z, and the weight 2000. That's mean pz equal weight equal 2000 Newton. That's all of this problem.
We have this example in 3D equilibrium. Determine the couples AC and DA and DB. And we have this position for A 504 per meter, and B 200, and C 034, and D 2 and 0. Now we'll find the position RDA equal 3I minus 2J plus 4K, and the magnitude for this dA, the 3 square and 2 square plus 4 square equal 29 and equal 5.4. The unit vector for this dA equal 3.4 I minus 2 5.4 J plus 4 5.4 K. This is the unit vector for this, and the RDC equal minus 2I plus J plus 4K, and the magnitude for this, and because we need the unit vector for this, this the magnitude for DC equal 21 and equal 4.6. The unit vector for DC equal minus 2 4.6 plus I plus 1 4.6 plus 4.6 K, and this J, and this the 2, and the unit vector for DB equal 0 0 minus 2j plus 0k plus 0k, and this I and the magnitude for RDB equal radical 4 and 2. The unit vector for dB equal minus j. Now we will find summation of x, summation of y, and summation of x equal 0 summation of x, and we will find the summation of y and summation of the summation of x. We have the unit vector this at Cartesian vector 3 4.4 and this for f dA minus 2 4.6 f dC equal 0, this 1, and summation of y equal 0 summation of y minus 2 5.4 f dA plus 1 4.6 fdc plus 1 over plus this 2 1 fdb, and summation of z equals 0 for z 5.4 fda plus 4.6 fdc minus 15 Newton 50 for this weight, and from 1 and 2 and 3 we will find the f d equal 26.6 Newton and f dc equal 34.5 Newton and f dB equal minus 947 Newton. And that's all for this example on 3D equilibrium.